Alright, here we go for parts 3 and 4 of lab number 3 in Signals and Systems. So, here is our model for the high-pass filter in part 3. We have the sine wave, we have a sum block, which we're not really using right now because we don't have the noise added yet. We have the transfer function for the system, and we have the scope. And the scope will give us the output that actually goes to the transfer function and the original input. So let's see, okay, there we go. Alright, so our transfer function is S over S plus 10, which is a high-pass filter. We have an amplitude of 1, and we have a frequency of 10 radians per second for this first test. And we're going to sample for 2 seconds. If we run that, because it's a high-pass filter, the sum will be higher than the transfer function output, as we can see there. But as we increase the frequency, let's say we go to 100, and we should change that to about 0.2, and we're going to run that. Now the outputs will be very close. So you can see the transfer function output becomes very close to the input, and that is because it's a high-pass filter, so the higher the frequency, the higher the output after the transfer function. Now for noise removal, we're going to add this other sine function here, which has an amplitude of 0.5 and a frequency of 10, which goes with the instructions. And the sine wave, or the input sine wave, should have an amplitude of 1 and a frequency of 100, which it is set like that. We sum them together, and let's sample them. Yeah, we can go for 0.2, I guess. Open up that scope, and we get the transfer function. As you can see, the sum kind of increases here, and the transfer function is kind of shifted down just a little bit from that sum. Alright, now on to part 4, the band pass filter. So for that, we don't need the noise for this part of it, and we need to change this transfer function. Because the band pass, there's a low pass and a high pass filter, and then they're cascaded, so we need to multiply the two transfer functions together. In doing that, we got a transfer function of 50 and 0 on the top, and on the bottom we're going to have 1, 70, and 1000. Alright. And then we're going to run just a few tests with this, with a few different inputs just to show what it's like. From that, the band pass is actually from 20 radians per second to 50 radians per second. So we're actually just going to go in the middle there, let's do 30. Okay. Let's do 0.5. Let's run that. And because it's in the middle, it will pass through at about an amplitude of 0.5. There. And now let's change the input to a frequency of 10 radians per second. So it's below the pass. And let's sample that for 2 seconds, let's say. As you can see, we have the sum, which is just the input, and then we have the output here. As you can see, it's less than 0.5 here. Because it doesn't really pass through very well. And then let's do a frequency outside of the range. Let's maybe do 70 radians per second. That's outside of the 50. We should expect to see, let's just do a 0.2. Should expect to see the transfer function be lower. Again, yep, it's lower. As we can see, the sum, or the input, has a much higher amplitude than the transfer function. Now let's see what happens one more test when we have 50 in there, we should. This is 0.5. We should see this very close, the transfer function very close to the input. And it's closer than the other ones. As we can see, it's about 0.5 for an amplitude, which again means it passes through. And that is all for parts 3 and 4 of lab number 3.